Hello everybody. We are now done with Battle Zone and I'm moving on to pole position. I have a pole position board set to look at. Today is February 28th and I want to say happy birthday to my twin daughters who turned 20 today. Miss you, love you, and hope to see you soon. All right. Pole position. Well, I'm going to start off with this. Everybody, this is a common popular thing to do is to run 5 volts and ground all over the board. I'll give my opinion on it. And if you're familiar with my channel and my videos, I like fixing things the right way. To me, this is a great big band-aid for a bigger problem. Nothing wrong with it. If you want to do this, the bulletproof thing, if you want to do that, that's fine. My opinion is, if you have to do this because your edge connector is so bad that you can't get a good solid 5 volts and ground to your boards, what else are you missing at the edge connector? What else is going on up there that's flaky? If you replace and you have good edge connectors, you don't need to do this. That's my contention. If you've got good edges and you've got good edge connectors, then you do not need to do this. That's my opinion. But I will take pictures of this and I'll make sure it goes back the way that I got it. But I need to remove this stuff while I work on this board set. But I just wanted my 2 cents on that. That's all. So I'll go ahead. I have to build a harness for this, so I got to pull up the pin out. Yeah, I need to grab the pin out and make my edge connectors and get ready to go. So let me do that. Let me take some time, make a proper edge setup, and we will get to it. Okay, I've been working most of the afternoon on this harness. This is my pole position harness. It's got 2 edges. It's got a 30 pin. I had to cut one down and make a 30 pin. That's got your this is to the video board. It's got your video outputs, and that's the power going in. This guy I'm powering off of my switching power supply, which this is the plug. It goes up to there, but this plug plugs into my switcher. Now this one goes to the CPU board, and it's got all the audio. And the audio is a little tricky on pole position. You got to combine a couple lines, and there's 2 channels. There's 2 audio channels. So what I've done is I've run both of my audio channels up to this guy, and you'll see here. What I can do is I have this going to my setup, but depending on what channel I want to do, I can put it this way, or I can just simply see how white lines up to white and brown lines up to brown, or I can flip it. Now it's the other channel, white and brown on the other side. So that's how I'm going to go between the 2 audio channels. It's a pretty elaborate harness. I just put that together, and I'm getting ready to put the pole position board set up on here and fire it up. Okay, so I have it hooked up and I have it plugged in, and I've checked the voltages. All this thing gets is 5 volts. That's all it gets. On both boards, 5 volts and ground. I've checked power on both boards and I'm at like 496, 4.96 volts on both boards. And remember, this video board here is running off of my switcher, and the CPU board is running off of my AR. So, and it is not doing anything. Blank screen. So we have nothing going on. I'm gonna have to check the clocks first and foremost. There's nothing on the screen. So first thing I'll do is I'll check clock signals and stuff like that. I'll flip this over, get to the CPU board. I need to look at the schematic a little bit, find out where things are made on this board. I think that's the first thing I'll do is I'll take a look at the schematic and go from there. I made my harness, I made the wires long on my harness because I have bought from DigiKey some of these connectors. Some of these back connectors are 60 position connectors with a pitch of 0.100. I bought like 5 or 6 of them or something like that, and what I want to do is make like a long connector with 2 of them to interconnect these boards, but I can lay the boards out next to each other instead of one on top of the other. That is my ideal for this. And I also have Star Wars ones. The Star Wars ones are longer. And the idea is I want to be able to lay the boards out next to each other and then run a connector to both of them. But for now, this is going to have to do. But I did, for the future, I did make my harness long so that the boards can sit next to each other, which is nice. But yeah, I'm going to have to kind of just turn this off. I'm going to turn that off. And I'm going to go over the schematic a little bit, find out where the main clock is made and that kind of stuff. So I will be back. Okay, this is the clock part of the schematic. And everything through here was looking great, no problem. This signal's present, this signal's present, but this signal was not present. So I got to looking at this business. And pin 14 of 7B has 12 megahertz coming off. But if I come over here, let's look at 7C pin 3. 7C pin 3. Okay. 7C pin 3. And you will see you got your 12 megahertz clock, and then pin 4 is the output. Looking good. And then that output, if we come over here, that output then goes to 6A pin 11. See that? 6A pin 11. So let's check that guy out. 6A pin 11. 8, 9, 10, 11. And 11 is a floater. That is a bad trace. That clock is missing. And I had a jumper between those two spots, and my screen went to just white. So I'm gonna have to take these boards apart. I suspect there might be some damage back here or something. I don't know exactly. I'm gonna have to take a look at it. Something's going on. There's a broken trace. So I'm gonna have to take a look. Well, guys, I was checking out what it was, a 6A, where it came, This signal went into 6A. There's a different revision of this board. This is the schematic for the revision of this board set. And you can see that 12 megahertz clock signal comes right off of that 047C pin 4. So that other business at 6A is not even involved in this. So I was barking up the wrong tree there. So yep, so just moving on, making sure that I'm using the correct schematic now. So no more rabbit holes to go down. So good doke. Okay guys, I'm going through sync chains. This is the schematic for the sync chain on the CPU PCB. This is kind of where it starts. This is a 07 custom that creates horizontal lines. This guy right here is what I'm looking at. It's a 163 and the clock comes in on pin 2, and then all we care about, we'll probe this load signal, but all we care about is the outputs on 14 and 13. So let's look at this guy. Let's probe pin 9, the clock, and 14 and 13. That is 6N. Oh. And I got a bunch of zeros popped up on the screen. Kind of comes and goes as it pleases. So this is 6N right here. So we're going to look at the clock on pin 2, which is the 24 megahertz off of the crystal. Okay. And we will look at the load pin. This is the load pin. There's your load pulse. Looks good. And here's pin 14. That's pin 14 right there. That is absolutely dead. There's 14. There's 13. This guy right here is not doing anything. So first things first and foremost, I'm going to replace this guy right here. Let's take a look. What does that signal exactly do? Those guys right there. Let's kind of zoom this in. Okay. Okay, 14, 13. You can see that 13 goes to pin 1 of that custom chip. So I think it clocks that custom chip. Pin 13 does, I think. And then 14 comes all the way over and goes up. And 14 goes through 368 in pin 4 and then out of pin 5. And then all the way back over to here. And it is the chip enable to this PROM chip. So we're missing stuff right there. So let's go ahead and replace that guy right there. Okay, I have the new 163 in the board at 6N right here. And if we look at pin 14, you'll see we get a nice, sorry about that, we get a nice clock. And then pin 13, we get a nice signal as well. So that is good to have that replaced. That's the first part of the puzzle. And we've gotten a little bit more going on here now. We still have a CPU board problem. I think our video board's probably going to be okay. I think this is probably a CPU board problem. And I don't have any of these Z8000s. Z8000 processors, I don't have any. And I don't know if they're bad. I might have to buy a couple. I wonder how much, I wonder if they're expensive. Z8000. Yeah, this thing's goofy. It's got a Z80 right here. That runs the sound. Z80 runs the sound. And then it's got two Z8000 processors here and here. And I have no idea if they're any good or... I'll just I'll get the schematic and I'll start probing around and seeing what they're doing. Check the reset pins. Just do some general probing around now. So that's what I'll do. I'm going to continue on that sync part of this schematic. Continue checking the sync and everything, because this really isn't that complicated of a board. There's a lot of custom chips. You know, there are a lot of customs. But yeah. But yep. I'm gonna just keep probing around. That's all I can do for right now. So I'll report back if I find something funny. I have moved on to microprocessors, the Z8000s. This is just the first one I came to in the schematic, so I started probing around this guy. I started probing around the control signals first and foremost. This thing has NMI. I think that's what that is. NMI. No, it's not. That's NMI. Whatever this is. This signal right here, whatever that is, comes from this 5N74. That control signal was just high all the time. So I'm looking at this guy right here. And let's take a look. Here we have the NMI, or the NVI, whatever it is on 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's that signal in question. And it comes from this guy, LS74. Pin 10 was pulled high by a resistor. So that's 8, 9, 10. That's pulled high with a resistor. Okay. And this guy, the AD05, was that address bit 5, maybe? Is on pin 12, which is right here. That is the data input. That is the data input, and it's floating. That's neither high nor low. That's a float. So that is a dead chip somewhere. And this is the clock, which is NMI acknowledge, which is always high. And NMI acknowledge, this signal, that clock signal. Sorry about that, got cut off again. But anyway, we were looking at NMI acknowledge. That clock's this guy. And that's just stuck high. And that comes from this PAL chip right here. And this PAL chip isn't going to output that signal, I would guess, because this thing is not going to run with missing a control signal. So I need to figure out where this what is that? AD0B? It looks like AD0B is what it looks like. So let me look for AB0B. All right. Guys, I think both of these Z8000s are bad. Both of these guys, neither of them are outputting any address bits. It's just floating. Every address bit is floating. Now, either this thing works different than I have ever seen a CPU, or they're blown out. You know, just not doing anything. Normally, if a CPU is held in reset or something, it'll at least hold the address lines either high or low or whatever, not floating. These are floating. There's no connection. So, I don't know. I'm gonna buy a couple of these, and I'm gonna order a couple of these from eBay and see what happens. Try to read up a little bit on these too, how these things work. Is that normal? If they're not running, they float the address bits. That's kind of weird. All right, well, I'm going to put this one on hold for a bit. I will be back. All right, pole position, back at it. I am kind of just poking around this CPU board, and I have a suspicion that there's something going on in the sound section that is causing this thing not to run. It's either a control signal that's generated in the sound system that is then dumped down to this area, or something weird's going on. This thing is like trying to boot. You can see it is trying. It just can't quite get there. So, yeah. I did put new CPUs, Z8000s, but I don't think that's the problem. Because those things, I believe, those lines, when this thing is not running and it's just stuck in a reset state, all the lines will float. I think that's perfectly normal, but it doesn't matter. I've got a couple of these now, so that's cool. But, yeah. I'm just going to continue to look at the schematic and try to find out. I'm following the reset lines from these CPUs back, and it led me to this area. And then some of this stuff, the control lines to these guys led me to this area, and these 367s and these ROMs and this RAM. So I'm kind of wondering if I just have a bad buffer. These 367s, I think, could be bad. The only way to really find that out, though, is to analyze them. So I think that's the next step, is I'm going to analyze these buffers. I think these 367s might be bad. So that will probably be my next move, is to check those guys out. All right, we're getting back into pole position, guys. And I created this. I bought the connectors, and I bought flexible. This is 30 gauge flexible wire. It's tinned copper, so it's a nice conductor. And I just soldered from this side to this side. And now I can lay my boards out like this. It's so much better. So much easier to work on. And I've got it fired up right now, and it's doing the same thing. Just garbage. But yeah, it's been a little while. Today is March 13th. So it's been a couple of weeks since I started this one. I haven't messed with it in about a week. And like I said, I just put this together so I can lay these boards out, which is really, really nice. So where I had left off last, I had to go back to my last video to find out where I was. I was talking about the 367 buffers and the sound section, and I am going to look at this power on reset circuit, because if that's not working, any power on reset circuit that's ever on a board, if it's not working, it won't boot. And that's the first thing that happens, is this power on reset circuit. So I'm going to make sure that's working properly. And then this is the next thing. The CPU right here is the first boot device right here. So I'm going to make sure that this power on reset circuit's good. Then I'm going to poke around in this section, kind of start over, to be honest. I had this board packed back up and was going to send it back to the owner because I just got discouraged, and I'll tell you why I got discouraged. This is why. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 custom chips. That's why. But I decided to get it back out, and I'm going to just assume that the custom chips are good, and that this is a failure in some other sort. So that's how I'm going to approach it. This makes things so much nicer and easier and less of a hassle. So this is a CPU board problem. The problem is on this board, first and foremost. So let's get this board doing something, and then we can go from there and hopefully figure something out. Well, the first mystery is solved. I just said, okay, I just kind of figured out through some research that this is the first boot device. So I said, well, let's just put a new one in there. This is the old Z80, the new Z80. I put in the new one. That one I know is good. And we got here. RAM okay, ROM okay. So that's good. But now we're stuck right here. So what does that mean? Let me just kind of I'm going to short the reset pins together and we'll see what happens. Okay. Come on. There we go. Yeah, it does its little boot nonsense and then comes up to that. So we're getting somewhere. Interesting. I think what I'm going to do, I have one of each of these that I bought. I think I'll replace these guys and see if that makes anything else happen. So let's do that. Okay guys, I am doing ROM checks. I pulled every ROM off of the CPU board and I'm just checking it. And you can see, okay. That guy was okay. These two are okay for this CPU. This one is no good right here. I gave it 5 tries. I got 5 unique checksums. Every one of them, I put every one of them against ROM ident, and they were all bad, and it never would verify to these. So this is just a bad ROM. These guys are all okay. So it's got one ROM for this guy that is bad, and the boot sequence for this is this, and then I believe this guy boots. So this one is where it's stopping, I believe. So we're going to put a good ROM in here, and hopefully this thing will take off and run. Okay, I've been doing a little poking around and analyzing around a little bit in this bottom part of the board here. I analyzed these two latches, they're address latches, and I analyzed these two address latches. Everything looks good. Then they get these addresses go, and I analyzed this guy, which is a 367, and it was working perfectly. These latches are working perfectly. We got good data coming out. These have all the signals that it looks like they need coming out. We're still doing this, but I have found something that is awfully suspicious. So I just started poking around with the good old scope. And this guy right here is a 161. This is the clear pin, so it clears every now and again. Okay. Let's check the load pin. Load pin looks like it's always high, so it's just going to free run. But look at the clock. This is pin 2 is the clock. It's just got a floating clock signal. That is not good. So I am going to have to hunt that signal down, that clock signal to this, find out what is going on there. So let me go back to the schematic, find this guy, find out what circuit it's in. Then when I find it on the schematic, I'll come back and we'll look at it together. Well, I have found the 161 that was in question, and you can see the clock signal is 128V. So it's a sync signal. And this looks like it's to do with the reset test. It's to do with the reset signal. So strange. But we're going to have to get that. I'm going to have to find this 128V. And I hope that's not made off of one of them 07 customs. But I'm going to have to find that guy. So let's do that. Let's find 128V. Okay, I am looking at the CPU PCB sync chain. And if you check out this guy right here, that's the 07 custom at 7M, pin 20 has 128V. So we're going to check all of these vertical signals. We're going to probe 18, 20, and 21. Okay? 128V is on 20. So let's come over to the board and let's move this guy, and here's that 07. So we're going to look at 18, which was 15, 16, 17, 18. There's a good signal. 19, 20. So 15, 16, 17, 18, 19, and 20. There is 128V right there. And 21 was 64V or something like that. So those signals are all there. That's 128V right there. That's 128V vertical. Now if we come over to this guy, 128V is supposed to come over to pin 2. We get on pin 2. And there's pin 2. It's just floating. There is a bad trace. So we have a bad trace from here over to here. So let's unhook everything here. Let's flip this guy over and let's take a look and see what's going on. I found our issue. This is the 07. Okay, if you look here, the short and quick of it is, this is pin 2 of the 161. This is the trace. This via right here is what goes to the back side of the board and comes over to pin 20, which is 15, 16, 17, 18, 19, 20. Now there is a connection. No, there isn't. There's like a connection to the socket, but not the chip. So the socket is bad. The chip is not making contact with the socket. See that? I'm up on the leg, and it's good metal there. It should be continuity, and there is none. But if I put my lead down the side of the leg and touch the actual socket itself, I think what I'm doing is I'm forcing the leg to touch the socket, because I think this is a single wipe socket where the inside of the leg hits the metal, you know, in the socket. The inside of the leg, it's not a dual wipe, it's one-sided, and the inside of the leg is what swipes the socket. And I think what I'm doing when I put this down in here is I'm pressing the leg to touching the socket. See that? Right here, there's no continuity. But if I push it, there is. So we have a bad socket right in here. These single wipe sockets, man. This could be a huge problem. If there's any more problems like that, I can honestly say that is maybe the first time I have ever seen that problem. Because these sockets are usually decent, but this one is definitely bad. So I am going to have to replace this guy right here, that socket, and then we'll get this thing counting at least. So it's in the reset circuit though, which is kind of strange. So I don't know. We'll see. Let's just fix it. Put a new socket in there. It's definitely a missing signal. So let's get this guy doing something and see what happens. Okay guys, I got a new socket put in here. So that guy has now got a good connection. As you can see by the LEDs, I've got it on. What do you think? Do you think it worked? How about that? Yeah. So we've got, I mean, it's working. I don't know. I really don't have a way to test controls. I'll look into it and see if I can get controls set up somehow. Yeah, I don't know. freaking cool. You know what? I'm going to call this one done at this point. But if I'll make an addendum to this repair video if I set up some kind of controls. I'm going to look at the schematic and look at the pinouts and kind of go through and see, you know, about it. At least like coin up the game and, you know, coin it up and try to play it or try to start it. Hear the voices and stuff. Let me do that. Let me look at the pinout. I at least want to coin up and hear the voice, hear the speech and stuff like that. And I imagine the speech and stuff is on the opposite channel. So let me look into that. I'll be back. Okay, I'm hooked back up. I did some changing. I actually did a lot to my harness setup. And we'll go over what I did in a little bit. But right now, I'm going to just go ahead and kind of fool around with playing a game and whatnot. I got coin mapped to my Atari joystick button. And I jumped this thing to auto start. So we'll go ahead and I'll put a coin in it. Auto start. And I got a 5K pot wired in for gas. Right now I have no gas. I'll gradually amp up the gas. My 5K pot. Here we go. Now back down. So I'm working this 5K pot. I don't have shift hooked up. And I don't have steering hooked up because I need a connector. I've got it wired, but I need a connector. So. Yeah, so what I did was, number one, I got this gas pot. This is 5K. I had to put a jumper between, you basically jump the brake to disable the brake or whatever. It's in the pinout. And then you had to jump 5 to 6 and 7 to M. You had to do a couple jumps and then do this. And I did make a little harness right here to hook my trackball up to do steering, but I don't have the connector. I don't have the connectors that go on the end, so I'll have to do that at a different time. So I'll have steering and gas. There is no brake. The brake option was only available in the sit-down version of this game. So, yeah. Yep, that's going to do it for this one. And I wired the coin up to this guy right here. Hey, and that's it. And turn the gas down. No gas, no movement. Yeah, so pretty cool. All right, I am going to call this one good, guys. As always, thanks for watching. And we'll see you on the next one.